Hello, I'm Kamal Vikramanayaka. This video is related to the full stack web development with the Java course conducted at the IT Center of the University of Peradeniya. In this video, I will demonstrate how object-oriented software systems are developed. To do this, I will take a simple example of a point-of-sale system. That is, in a shop, you find that once a customer buys some items and comes to the cashier would use a system into which the items, details of the items purchased are entered, and finally a bill would be produced. So that is a point of sale system. In this video, I will take that as an example to demonstrate how software is developed using object-oriented techniques. Beginners to object-oriented software development often find it difficult to figure out how the requirements are transformed into classes, objects, and compose these objects so that you would have the final software. So one purpose of this video is to give you some clarity as to how the requirements are broken into the classes and finally objects, so that ultimately you will have a collection of objects interacting with each other when the software is executed. So this process of breaking down a system into smaller parts is known as decomposition. So we will look at how a system is decomposed in terms of object-oriented programming. I will be using Visual Studio Code integrated development environment for this purpose, and Maven as the build tool. I will also use an extension for Visual Studio Code called Umlet to draw some diagrams. So typically, even though when it comes to a typical software development project, you don't go about starting with the IDE. Here I'm going to start with the IDE and make sure that the extensions are installed properly, and then I will get the requirements described in a text file open, and then I will use Umlet, the extension, and come up with the diagrams, and finally do the diagrams. I will do one diagram after object-oriented analysis, and then after the object-oriented analysis, I will produce another diagram to represent the design of the system, after which I will code the system in Java. So let's get started. Okay, as I said, even though in real world projects you don't start with the IDE first, I'm going to use the IDE and show you how various diagrams are created and so on as part of the initial steps. So I will create a new Maven project. So for that purpose, I will go to the command palette, and then I can start typing Maven, and I will use a certain archetype for this purpose, but for the first time I would like to update Maven archetype catalog. Okay, it's done, and then I will get the command palette again, Maven, new project, and I will use the quick start archetype, and I have version 1.5 here, and then I am supposed to enter the group ID since the group ID, what we use as the group ID is typically the domain in reverse order with some additional parts. I will use the IT center's domain in reverse order. PDN for Peradeniya, CEIT for the IT center, and I will use POS to represent the group ID. And then what is the artifact ID? I will say point of sale, and it asks me to select a destination folder, Kamal CEIT. I will create another directory here called Kamal, and I'll select that as the destination folder, inside which another folder would be created for the Maven project. Okay, so the tool is asking me to enter the version. I'll accept it as it is, and what I have entered so far, the additional properties, I'll accept them as well. And now the project has been created. I would like to go about opening the project directory in Visual Studio Code. So for that purpose, I could have clicked on the link that you saw in the pop-up window here, or else I would go and select open folder, CEIT Kamal point of sale. That's the project that got created. I will select it. Okay, we have the project open, and let's check the Java version. The Java version is 17, but we are coding with the Java 25. So I will change this. I will remove this and save it as 25. So the build file was modified. I can click yes and do a synchronization of the class path properly. Or else I should be able to do so from another place as well. If you look at Maven project here, point of sale, well, what I want to do is I want to reload projects so that the version would also be proper. Okay, so version 25 is being used now. And the package based on the group ID has been created here. That's fine. But I'm not going to code the project directly because I don't even have the requirements as of now. What I will do is I will get the requirements in a text file added to this project. So I'll create a folder and I'll name it docs, that represents documents, and inside this I will create well, I have a file that I would like to copy to this. Let me go to that place, CEIT, full stack with Java, OOP, docs, requirements file. This is the file that I want to copy. I will go to the newly created project docs directory and I will paste it here, and possibly I should be able to open it in the Visual Studio Code. The problem is it's not wrapping. I wonder how to display, how to wrap it. Do we have Let me quickly search. VS Code, text editor, wrap words. Okay, Alt Z. Does that solve the problem? Alt Z. Let's go through the requirements to understand this system in brief. A point of sale system needs to be created. A customer comes to the cashier and the cashier takes items from the cart and enters the item IDs into the system. For each item type, the system asks the number of items to be purchased. The system creates a bill and adds line items to it. At the end, the total is calculated and the tax should be added. The system should ask to enter the amount of money the customer would give. The system should print the entire bill with the balance to be given back to the customer. So, the requirements of a system is described in a paragraph of text here. In real-world software development, you may sometimes find paragraphs of text like this, or else there are other ways to describe functional requirements of a system, like by using use cases or user stories. In our case, we simply use this paragraph of text as the requirements. The next step is to figure out, or I would say that the next step is to analyze this real world problem further, so that we would be in a better position to come up with the design. So we have the requirements now, we would analyze, and the output of the analysis will be used for the design, will be used in the design phase. So what we do during analysis is that we would try to understand the real world problem domain well. We will create a domain model for that purpose, which would describe the real world, the problem domain that we are dealing with. So for that purpose, we to create a domain model, I will use Umlet, which is an extension for VS Code that can be used to create UML diagrams. If you do not have Umlet installed already, go to the extensions, and here you could have first installed extension pack for Java, which I have already done it, which I have already done, and Umlet. See, you can select this and you can install it. In my case, I have already installed it. This is a very simple UML editing tool, UML diagram editing tool. They say that to create a new diagram, create a text file with the UXF extension. So after you install it, it's possible to create a file with the UXF extension and go about adding items to the diagram and so on. So going back inside the docs directory, I will create perhaps a new file with that name, or else it's also possible to go to the command palette and type umlaut. So it has the create new diagram option. If I select it, a file is added based on the the name is automatically identified based on the date and time. I will rename this. Let's call this 02 domain model, and I would move this to the docs directory. Okay, so I have the requirements, and from the requirements I am going to create the domain model. So this is the output of the analysis. While we do the analysis, we will go about completing this diagram. So when it comes to object oriented analysis, OOA, what we do is we first go through the requirements and identify what are the classes and attributes of them. So in this case, we can go through the sentences in this description and identify the nouns which would be the candidates to be added to the domain model as classes or attributes of them. So in this description, if we read the first sentence, a point of sale system needs to be created. Well, that's the system to be created. Sometimes you may or may not want to draw that because that represents the entire system. But here, a cashier is going to use the point of sale system. So just to understand the real world domain well, let me go about adding that as well, the point of sale system. So in umlaut, you can select UML class category here, and I would double click on this so that a simple class is added to the diagram, and the class details can be edited here. So point of sale system. So that's the okay, point of sale system. And then what are the other classes and attributes that I can identify? A customer comes to the cashier, and the cashier takes items from the cart and enters the item IDs into the system. There are multiple nouns here. A customer, so there is a concept called customer. Double click on it. So we have so this, change the property. So we have a concept called customer, and then cashier. So that's another noun. So I will add another class. Sorry, if you double click, it duplicates the diagram. Cashier. And then cashier takes items from the cart. Okay, so there is another concept called item, and then cart. takes items from the cart and enters the item IDs into the system. So item IDs. So the items available in the cart, the class called item, that seems to have an attribute called item ID. So we can go back to the item and add 2 dashes here, and then I can say I can add item ID, and I can even specify the type of it. I'll say it's a string type. Okay, I'll save it. The cart would have multiple items. Even that can be shown in this diagram. So how to do it? I will actually go to the preferences, themes, and change the color theme here to VS Code Light. Okay, I just changed the color theme, and here is the relationship the notation that can be used to represent the relationships. So I'll go about double clicking on it, and this is added to the cart, and this is to the item. So this says that the cart has an association with the items class, and I can even go about describing how many items may be related to a single cart by editing the properties. You see, it can be so I want to display asterisk here, meaning multiple items may be available in the cart. So to do so, I need to learn now this. Let me just add this, and see, M1 is equal to, so this is multiplicity is specified with M1 and M2. So if I select this, let me add M1 is equal to X. Okay, it's added to the top. So if I add M2, it's added to the bottom, and if I add that, okay, so I did not want to that. So here a cart may have multiple items. So an aggregate is shown by this association symbol. A single cart may have multiple items. So even that is represented in the domain model now. And then for each item type, the system asks the number of items to be purchased. So the number of items is another noun that we find here. So we need to go about adding the number of items to the domain model to a certain class. But it's not very clear immediately where we should show it. So we'll continue reading. The system creates a bill and adds line items to it. So a bill is to be created, and a bill should have line items. So again we find two nouns here, two new nouns here, bill and line items. So to the domain model, we can go about adding a new class called bill, and then line items are added to the bill. So we can add a class called line item, and we can go about associating a bill with a number of line items. A single bill may have multiple line items, and line item is associated with a certain item and a certain quantity. The number of items can be captured in the line item class. So line item, 2 dashes, quantity, and I will say that this is going to be an integer. But in real world, you see quantity may not necessarily be an integer. For example, there could be a certain item type, which is where the quantity is measured in kilograms or sometimes in liters. So it's not going to be integers always, but for simplicity's sake, in this demonstration, we will simply assume the items that are purchased are bought in quantities where we can represent the quantities with whole integer numbers, whole integers. So quantity is going to be an integer, and we can show the relationship here as well, and I will use the composition relationship here. And a bill may have multiple line items. M2 is equal to asterisk. So I used two notations to represent the cart with items and bill with line items. So here the head is filled in black, but here it's not filled, it's just a white. Why I changed the theme in Visual Studio Code is that when I use black, the this unfilled aggregation symbol here it is shown in black, and this one is shown in white, which is wrong. So that's why I changed the color, just to show you. See here, this is white and this is black, the fill color. And if I go back to the preferences, theme, color theme, see, if I select black, see, this becomes black and this is white. So that's why I wanted this to be white and this to be black. That's why I changed the theme, color theme, to a light theme. Okay, now the correct color is used as per the UML notation. This relationship is called an aggregate relationship. This relationship is called a composite relationship. The distinction is that when it comes to composition, the idea is that a line item cannot exist, or line items cannot exist if there is no bill. So you need to have a bill, and associated with the bill, line items would be available. But here it is different. A cart may hold multiple items, but without a cart also items could exist in the world. So a cart with multiple items is shown as an aggregate here by using this symbol, whereas a bill with multiple line items is represented as a composite. So that is represented using a different symbol here for composition. Anyway, going back to our description, we'll read again. For each item type, the system asks the number of items to be purchased. The system creates a bill and adds line items to it. At the end, the total is calculated and the tax should be added. So, total, the bill is going to have a total. So, we will show that as well. And what is the type? You don't have to necessarily describe the type here, but maybe I'll just omit it for the time being. And now it's not very clear, so we'll do it like that. Okay, a bill has a total, and the system creates a bill, and at the end the total is calculated and the tax should be added. So there needs to be another property here, the amount of tax added. And I added it to the bill because the tax would be added to the bill, should be added. The system should ask to enter the amount of money the customer would give. So where should we show that? The amount of money the customer would give. Perhaps it's to be added to the bill. Perhaps it may not have to be added to the bill because maybe the amount given to the cashier, the amount of money given to the cashier, and the balance. So these two sometimes may not have to be captured in a bill, but sometimes some customers may prefer to have that information captured in a bill as well. For simplicity sake, I'll just add those two into the bill here. So we will say cash given by customer and balance to be given to customer. Well, since they are lengthy, I'll just remove this part, balance. Cash by customer. Okay, so what else? The system should ask to enter the amount of money the customer would give. The system should print the entire bill with the balance to be given back to the customer. So we have gone through the textual description of our system. We have identified the nouns in the sentences and went about identifying the classes, and then some of the nouns became classes and some of the nouns were added as attributes of classes. We can go about analyzing additional text that we might have, or you can put your own domain knowledge and complete this diagram. For example, point of sale system and what's the relationship between the cashier. So those things you can go about identifying. If you ever need, you can show the relationships between them. You can go about identifying additional classes and additional attributes and then even the associations between them. For example, a line item has a quantity, but a line item is related to an item. A given line item is related to an item. So, to represent that, you may go about coming up with an association here, or show an association. A line item is associated with an item. So, you can go about using what? Maybe this. You can represent these in different ways. Right. So here it's going to be 1. A given line item will point to a single item. So, to represent that, I just added 1 as the multiplicity of this relationship, of this relationship. So, you can go about coming up with associations between the point of sale system and the cashier and the customer with additional classes here. For example, you can show the relationship between the customer and the bill. You see, even that is an association which might have to be represented in a certain system. If software project is to be developed in such a way that even that association should be captured in the system, you may go about adding an association to do so. So, this is an incomplete domain model, but based on your domain knowledge, that is the knowledge about the point of sale systems, you can go about adding further details. So, this diagram we can consider it as the domain model, the output of the object oriented analysis phase. So, during object oriented analysis phase, you go through the requirements and come up with a domain model. So, that is coming up with a domain model is just one step that we can take towards coming up with the final software. So, assume that this is the output that we use now, that we are happy with, so that we would jump into the design step. So, we can if you ever want, actually this Umlet tool allows you to export the diagrams into image formats. So, for example, view, command palette, you can type Umlet. See, you can export as a PNG or export as a PDF. I will select that and it asks me to enter the directory. I will say domain model.png, save, and let's open it. See, well, it's I press the control button and then I can zoom out. Okay, so exporting to a PNG would be useful if you want to add this to a document also, but right now I don't want this. I just wanted to show you how it is done. In the with the source code of the project, there is no real requirement to maintain the PNG files, because we can use Umlet whenever we want, either to display the diagram within the IDE. But if you ever want to come up with a PNG file, that can be done by exporting this by using the exporter facility available in this tool. Umlet is available not just as an extension to Visual Studio Code. You can download it as separately from Visual Studio Code and run it as a standalone application as well. So even with that, you should be able to open the UXF files, and even if you want, create or export into various other formats. Okay, the next step is that we would look at how to come up with the design. So we have done the analysis, we have done the object-oriented analysis, and as the output we have created the domain model. So the next step would be to design the system. So we will be looking at how to perform object-oriented design. So that is the place where real classes are identified that we would like to code. If you look at the domain model, here also we came up with a class diagram. So bill is a class, cart is a class. So these are classes available, but we say that these are in the real world. So they are in the real world. The domain model represents the real world, but they do not represent the classes in the actual system that we are developing. Some of these classes may map to the classes in the design, but the design, in the design phase, we identify the classes that we would code from which objects in the computer domain are to be created. So if you look at this one, customer is a class in the domain model. An instance of the customer is a real customer. An instance of the customer class is a real customer. But in the design, if we come up with a class diagram for the design and come up with a class called customer, an instance of that customer would not be a real customer, but just a representation of a customer in the computer domain. So as the next step, I would create another UXF file to represent the design. New file 03 design.uxf, and I would again like to draw a UML diagram, and I would like to save this. And then okay, so then my requirement is to identify the classes available in the computer domain. You can start by looking at the classes available in the domain model, and some of these classes, sometimes all of them will map into the computer domain. But you need to distinguish between these two. So here we have the real world entities are represented, real world entity types are represented, but here we represent the actual classes. Here we represent the classes related to the software domain. Okay, so even in the software domain, if we look at the bill, line item, so we may prefer to have them shown. I wonder if I can just copy and paste these. Right, good. So that is easy. Okay, let's say that I do not want to represent the cart in the computer domain, but a bill is to be represented. So I am interested in perhaps the field types as well. So total, what is the type? Maybe if you are writing in Java, big decimal class can be used to represent that. Tax can also be represented with a big decimal class, and cash given by customer, and the balance may also be shown using the big decimal type. Quantity integer, okay, and then the bill and the line item relationship is such that it's a composition, and then we have the item ID, and you might want to add the item price as well, because well, you could have added it to the domain model as well. I forgot it. Well, that's normal, because you in iterative software development sometimes you forget things, and we may go about adding them later on. Item ID, what's the price? Or you can better say unit price. So here also okay, so what else? Bill, let's say that in the computer system or the software we don't have to represent the customer. If you ever need the cashier may be added. So who created the bill? So many systems would like to show that in the bill. So we might want to add the Control C and Control V. So cashier, I will just use this and add it to this. So if we represent it like this, it means that a given bill will have a reference to a cashier. Let's say that I don't want a multiple. So in that case, a bill will have a reference to a cashier, meaning that only one cashier is allowed to create a bill. So let's assume that that's how we want to model it, and then okay, so we have created, well, I forgot, maybe we need to add the cashier name, which is a string type, and cashier ID, which is also a string type. So you might have those details, attributes like this added. So some of the domain model classes that appear here, we simply added them to the design, meaning that we would like classes to be written based on what we have added to this design. But you see, you need to be mindful about some additional details like a bill associated with line items. You see, if you look at this, a bill is associated with multiple line items. A given line item is associated with an item. you can have this relationship as it is in a simple system, but what happens on a following day, the unit price of a certain item is changed. So in that case, let's say that today we create a bill, and associated with a bill there is a certain line item which is associated with a certain item, but the price of the item changes tomorrow. So if the bill is to be printed again for whatever the reason, perhaps the customer comes tomorrow and asks for a bill, if on the following day the price is changed, you see, how do we go about generating the previous day's bill? So we cannot directly keep information like this. Perhaps we have to remove this relationship and have the item ID and unit price added to the line item instead. Because the objects that are created from these, ultimately we want the details of them saved in maybe a database. So to facilitate changing prices of items, we might prefer not to maintain this relationship, but instead in the design to go about adding the properties to this. You see, item ID, we would like to copy from the item, and quantity is this much, and unit price is big decimal. So we might model it like that, model it this way. The idea is that today if we go about creating a bill with certain line items and save the information in a database, tomorrow if we go about accessing the same bill, we would be able to have the information fetched from a database, even if the price of items may have changed. The line item prices don't change if we model it like this, but the item prices may change from time to time. So for that purpose, we may want to not associate these two, line item with the item in the design, so that it facilitates changing prices. And another thing that I forgot is that a bill ID might also be something that is interesting. So ID. So I added it to the domain model, and I would also like to add it to what's the type of the bill ID? Perhaps an integer. Okay, so what we have created so far is what we have created so far includes the entity types that we find in the domain model. But where exactly the logic of the system is captured, still we haven't created them. So our system would need to have a user interface. So let me assume that we would have a class that represents the user interface. So I'll call this text UI. So it contains the user interface related logic, and then the point of sale system core logic is to be captured somewhere as well. Perhaps what I can do is I can go about capturing the details in another class, the core logic. So let's say that there is a point of sale system. There's a class called point of sale where we would like to capture the core logic related to the point of sale system, and these classes, they represent various entities in the system where we would like the details or the attributes of them or the information, the data captured in them saved in the database. Cashier, bill, line item. So we want them to be saved in the database. So I will call these domain classes or maybe entities. Point of sale, let's say that captures the core logic of our system. And text UI would go about using the point of sale class, which contains the core logic of the point of sale system, to represent that. The text UI is a class to be written, an object from that would be created, and point of sale is another class to be created, an object from that would be created. So text UI object would ultimately access the point of sale object and invoke various methods available here. What are the operations available in the point of sale system needs to be created. We can go about reading it again. The customer comes to the cashier and the cashier takes items from the cart and enters the item IDs into the system. So here, through the text UI, the cashier first needs to go about creating a bill. That is not described here, but you need to understand based on the domain knowledge. The first step would be to create a new bill. You could have gone about writing that in this description as well, but sometimes the descriptions might not contain all the details, so you may want to directly add these kind of details into the diagrams if you want. So the choice of adding the newly identified details or making the requirements more clearer, so that choice is with you. I will simply go about not updating the requirements document in my case, but if you like, you can do so. So point of sale system needs to have a behavior called start new bill. So here is a certain behavior that the point of sale system has, point of sale class has, and through the text UI, it should be possible to invoke the start a new bill method available in the point of sale object. So the text UI needs to have a reference to the point of sale class to do that. So let's go about adding this. Text UI would maintain a reference to the point of sale, and it's just going to be one point of sale object to which a reference is maintained. So what should happen when the start a new bill method is invoked from the text UI? Let's say the customer comes to the cashier and the cashier enters into the text UI something. Maybe if it's a textual UI, you have to type a certain word into the system. If it's a graphical UI, you might click on a button. So in this case, we will assume that it's a textual UI that we are using. So a string like create new bill or press C so that a new bill is created. So start new bill. What should happen? A new bill object needs to be created. So a new bill object needs to be created might itself include logic, whereas a new bill ID is to be identified based on a certain pattern, or based on based on the previously created ID, the last created ID. So perhaps to capture the logic related to the bills, logic specifically related to the bills, we might go about coming up with another class. Maybe let's call it a bill manager. You see? So the point of sale class, a point of sale object, contains the start a new bill method, and maybe the bill manager also has the same method. The purpose of which is to create an empty bill. This is the return type. So an empty bill is created when the create new bill is invoked. So the point of sale object, let's say, needs to access the bill manager in fulfilling the start new bill operation. Well, I used a different name. Why not I used create here? Just to maintain consistency. So, if the cashier uses the text UI and start creating a new bill, the UI invokes the create new bill method of the point of sale object, and the point of sale object may access a bill manager and invoke the create new bill method, which would create a bill and possibly assign a bill ID and return it. So perhaps that is maintained in the point of sale object as a private field. We will call it so there is a so there is an attribute called current bill within the point of sale class, which will be set to the bill created by the bill manager. So to this, the new items can be new line items can be added. Okay, so I want to go about associating the point of sale with the bill manager as well, because I said that the create new bill method would access the bill manager. So again, I will use this. Oh, I already have it here. So this. Well, it's possible to go about reading these, reading the requirements again, and go about completing a design. Sometimes you see, you might use an iterative approach in clarifying the requirements, clarifying the domain model, and again updating your design. So that's normal. So if you read the requirements for each item type, the system asks the number of items to be purchased. So you see, now what happens is that line items to the bill should be added. So the cashier takes items, and for each item a new line item, for each item type a new line item needs to be added to the bill, so item ID needs to be requested by the text UI. So text UI would go about prompting the cashier to enter an item code, item ID. So if the based on that, the point of sale class, point of sale object ultimately would have to go about adding a new line item to the bill. So we might add another operation here in addition to the create new bill method, add line item method. Okay, so we went about adding the add line item method, meaning that the text UI might invoke the add line item method. So at that point we want a new line item to be added to the bill, and sorry, maybe we can code it here, bill manager. We'll make some slight adjustments. The current bill, maybe we'll not have it here. The bill manager, let's say, would contain the current bill, and add line item method, if invoked on the point of sale, since it is an operation that is more associated with a bill, let me add it to this class as well, add line item method. So if the text UI invokes the add line item method of the point of sale, the point of sale object would invoke the bill manager's add line item method, which would add a new line item to the bill. So that's better. And we might be interested in thinking about the parameters that are passed as well. Text UI, when it says add line item, what are the parameters that should be passed? Maybe the item ID needs to be passed and the quantity needs to be passed. So item ID, which is a string, quantity, let's assume it to be an integer. So those are passed to the point of sale. So we add it here. Okay, that appears to be good. And sometimes you might wonder why exactly all the logic is added, why not all the logic is added to a single class, like point of sale. Why exactly the method create new bill here as well as create new bill here. This actually depends on partly your preference as well as a separation of various concerns into various classes. Since a bill specific operation is related to, since there might be a number of bill specific operations in a point of sale system, in this case, I assume that I would rather create a bill manager class and add such a bill specific logic into this class. So point of sale might have other things as well apart from bill manager, bill creation. For example, it might have return item management related code. We might have in another class. So then cashier management detail management related code which we might have in another class. So like that there might be different concerns available in a point of sale class that is preferred to be coded in separate classes. So that's why in this case I assumed I thought that I would have a separate bill manager class and have all the bill related logic here, instead of having all of these in the point of sale class. But I use a single reference to the point of single object reference from the text UI, because you see I can go about having additional classes for return management, cashier management and so on in other classes. But even if I create other classes, I would still have a single point of sale reference or an object to a point of sale object passed to the text UI. So any logic in the point of sale system to invoke any logic, the text UI would have to go through the point of sale class. So point of sale class would delegate the responsibilities into the bill manager, return manager, cashier manager and so on. So that way just a single object reference is maintained in the text UI, and I can go about making adjustments. I can even go about changing how the internals covered by the point of sale object is. I can go about making adjustments to the internals of the point of sale system without affecting the text UI. Text UI only knows about the point of sale. How these methods are implemented, I can go about making adjustments as I wish, so that no changes would appear here even if I make adjustments to the internals. Okay, so add line item. So the purpose is to add new line items to the bill, and the total is calculated and the tax should be added. Okay, so that is another thing. So tax should be added. We need to have some kind of a tax calculator here. So we will go about adding that as well. So our system is going to be complicated. Even though I added this, I'm not going to code it for simplicity. Tax calculator, you see, certain items may have no tax to be applied, and certain other items may have specific tax amounts to be added or associated with. So you see, it's going to be related to the individual line items. So the tax calculation, actual tax calculation, is going to depend on the items. So it becomes complicated. So perhaps maybe in this demo application I might not code it, but you see, but the idea is that a tax calculator needs to come into the picture, and the system should ask to enter the amount of money the customer would give. The system should print the entire bill with the balance to be given back to the customer. So perhaps we will model that. The money given by the customer. So the text UI, the cashier will enter the amount into the system. Cash by customer, maybe entered as a string. Sorry. So perhaps we will add it to this as well. Okay, so we have done it, and then ultimately the system should print the entire bill with the balance to be given back to the customer. So print, there needs to be a print operation. Maybe the print operation we will have it in the text UI, because it's related to the user interface here. Of course, if you are going to do an actual printer, maybe a printer needs to be added to this class diagram, and methods like print, printing a bill should be added. So here in this case I am just going to print the bill to the screen. So I would add print bill. So there is going to be an operation called print bill. So additional details needs to be available because our diagram is still not complete, but we will talk again. The cashier comes and uses the text UI and invoke the create new bill method, which would trigger the create new bill method of the bill manager, and a new bill is internally created. The bill reference, the bill object, is returned by the create new bill method. So the point of sale would have the create bill returned within this method. Maybe this method is also written to return the bill to the text UI, so that at the end the print bill method can simply have the bill printed, because the bill is available, a reference to the bill is available. And then the cashier enters the line item details, the item ID is entered and the quantity is entered. You might have additional methods like search for items. So because the cashier might want to search for a certain item, so that the item ID is identified, and then the item ID and the quantity might be entered. So additional methods can be added. And for searching items, perhaps you would like to have an item manager similar to the bill manager. So why not we have that as well. So we will have an item manager, and so this might have methods like search items, maybe a name is given, maybe a query string is given as Q, and the purpose would be to return a list of items matching that query name, query string. So item manager, we might go about adding methods to facilitate the same. So this is something that I added in addition to the basic operations that I wanted to implement in this demo. But anyway, the idea is that while you go through the requirements, you might go about updating your designs, updating your design. You might also go about updating the domain model and even go into more details or clarify or update the requirements as well. That can happen in iterative software development. Okay, so the cashier searches for the items, and then let's say that the cashier enters the particular item ID and the quantity, and the bill is added with that, because the bill manager has the method to perform this add line item method. And once everything is fine, everything finishes, since the bill is available, printing the bill is method can be invoked to go about printing the bill to the screen. However, there needs to be a way to end the bill to finish the billing process. Maybe to represent that, we will have a method called maybe a method called finish bill, or maybe end bill. So bill manager would also probably needs to should also have a similar method. So this is a rough design. And perhaps I should go about showing you how the system is coded. Otherwise, this would be boring when I go about explaining the methods and how these things are working. So when you have code, you will gain more clarity. So I should switch to coding and demonstrate how coding is done. But still the process, you understand that it is thinking about what the cashier does using the UI, and adding related methods to the point of sale class, and then delegating or figuring out which other classes within the system should have the corresponding logic implemented, and based on that implement the operations in specific classes and get the job done. So this way we can go about adding new behaviors to the classes. But something that I would like to do is that I would like to rearrange the classes in a slightly different manner, so that we follow some best practices in designing systems. When systems are designed, we would like the code to be written in such a manner that we can easily switch to different implementations of classes. For example, take this tax calculator, which might have which might have implemented the logic to calculate the tax for a certain period of time. Perhaps the government comes up with new tax rules. So we might prefer to use a new tax calculator within the system so that the new tax logic is also captured in the new code that we write. So we don't prefer to go about making adjustments to the already available code. We would simply want a new tax calculator to be replaced. The old tax calculator to be replaced with the new tax calculator, which contains the new tax calculation logic. So the same holds true for the other parts as well. For example, you see a better bill manager. Maybe a bill manager is written in such a way that the bill details are saved in a text file. Subsequently, a different bill manager may be written in such a way that the bill details are saved in a database. So one bill manager uses text files, another bill manager uses a database to maintain the bill related data. So you see, like that, there can be different implementations of classes in a system that we would like to switch. We would like to switch between based on various requirements. So because of that, what we typically do is that when we have core classes within a system containing logic, we would like to extract the interfaces of the core classes and have implementations in different classes. For example, if you look at the point of sale class, here a number of methods are available, and we would prefer this to be made an interface and have a separate class containing the implementation logic. So let me just make an adjustment so that it will be clear to you. So I need more space here. Point of sale, Control C, Control V. Sorry, I will call this point of sale implementation, and this I will make it an interface. And then the relationship is such that this class, I want to say, implement this interface. So the idea is that we write an interface called point of sale, and here is a certain implementation class. The text UI is written to the interface, and because of that, the text UI does not invoke specific methods that may be available in the point of sale implementation class. It simply depends on the point of sale interface methods. If you draw the diagram like this, so the text UI would depend on a point of sale interface. Any object that implements the point of sale interface, it would be happy with that. And in a real system, we may have multiple point of sale implementation classes. So if you prefer an advanced point of sale implementation class that can be implemented separately, and an object from that can be created and given to the text UI. The text UI would simply assume that it's yet another point of sale interface implementing object. So without any modification to the text UI, the point of sale, the other point of sale implementation object may be used. So here is the class, and here I would like to be like this now. And bill manager can also be implemented in that way. Okay, we will have another one. Sorry, we will make this an interface. Interface would not have property attributes. Sorry, bill manager IMPL. The bill manager IMPL implements the bill manager interface. So if you wish, a different bill manager implementation can be implemented and passed to the point of sale class. So it will work without any modifications to the point of sale implementation class, because point of sale implementation class is written to use the bill manager interface only. So item manager, perhaps this can also be made an interface. IMPL just to mean interface. So this might be our design. Still, you see, you can argue about various things and go about updating. As I said, for example, the tax calculator, how it is to be incorporated into the design. I just drew it here, but didn't go about associating it with any place, any other class. But it's possible for you to think and add it in a suitable manner. So like that, there are other things that we can do. But for the sake of simplicity, let me not go into more details. But let's assume that this is a reasonable design, which is still incomplete, that we are happy with for the time being. So we may go about coding this as well. So next what is to be done is coding this. So while coding, you might get a better understanding of why things are done in certain ways. But you see, the idea is that once a design is created like this, it is easy for us to go about writing classes. So this diagram contains many details which we can directly transform into the code. If we look at our domain model, you see it is not as I mentioned, it represents the problem domain, the real world, and now we have more details here. This diagram is represents what is in the computer domain. So in the computer domain, the classes, interfaces, and so on can be coded now. So where to start coding? We understand that if you look at these interfaces and the classes which contains core logic, even the text UI, they will depend on the classes that are shown here. So one of the easiest ways to go about coding is first go about coding these entity classes. You go about coding them and including the relationships, and once that is done, you can switch to the interfaces. And once the interfaces are done, you can switch to the implementation classes. And perhaps in this case, finally you can focus on text UI. But even text UI, when the point of sale interface is written, it's possible to go about implementing text UI, because the internals of the point of sale system are hidden from the text UI. Text UI only knows about the point of sale interface. So once the point of sale interface is written, just the interface, not the implementation, when the interface is available, text UI can be written. So like that, the exact order to be followed in writing these classes is not that important, but interfaces can be written first. As I said, the very first thing would be to go about coding these entities, the types, the classes that represent real world entities. So they can be coded, and then the interfaces, and then you can go about coding the actual classes, implementing the interfaces. So let me go about coding these, maybe the bill, line item, and item. Okay, so the point of sale, I would like to create different packages to organize my code. The UI related code in a new package, I will call it UI, and then I have the entities here: cashier, bill, line item, item. So I create a new package. I'll call it entities, and alright, that might be good, but if you want, you can break the system into more packages for organizing the code. Okay, so the entities, I will first go about coding item class. Entities, I would add a new Java file, class item, which contains item ID and unit price. Do we need to have the item ID here? Perhaps only the ID can be added here. Okay, so ID and unit price, item. And if you wish, you see, you can even specify the access, the encapsulation related details, the access specifiers. So if you add like this, the properties needs to be private. So private ID and private unit price. So you can add this private string ID, private unit price is big decimal. You start typing big decimal, which is available in the Java math package. Unit price. So you note that just as I selected the big decimal type in the Java math package, the import statement got added automatically. And I forgot, an item name should be available, right? ID and unit price. Do we have item? Here also, item ID, name, private string, name. Okay, so we can go about adding constructors and access methods to this class. Right click, source section, generate getters and setters for the ID, name and unit price. Okay. And for the sake of creating an item, perhaps we need a constructor as well. Generate constructors with all of them. And sometimes it is also needed to have constructors without any parameters. So generate constructors, I will simply add that. So nothing is done. And sometimes the objects you might prefer to print directly using the system out println also. If an object is printed using system out println, the toString method of the class gets invoked. So toString method can be added to this as well. Source section, generate toString. So what are the properties that you are going to use to generate toString? Maybe these. Okay. So item ID, name and unit price is shown. Okay, so the item class was coded, and line item also I added the name, right? Where is the name? And line item also, item ID, item name, okay, so we will add the line item class, entities, new Java file, class, line item, and item ID, this is a string, line item. So I look at the diagram, item ID, item name, private string item ID, private string item name, and then quantity unit price, private integer quantity. private big decimal unit price. So they are the properties, the attributes in this class. So I can go about adding the getters and setters. And perhaps I want a constructor as well. Constructors, item ID, you could have selected all of them in one go if you wish. Source action, generate construct, source action. You can just pick that, and all of them get added. And perhaps you need no argument construct as well, constructor without anything. And then if you ever want to print for testing purposes and so on, you might want to add the toString method and these properties. Okay. So this returns a string which can just be printed with the system out println. So the line item is coded, line item class is coded, and then the bill class, new Java file class. So we look at the diagram. Bill has an ID, private integer ID, and then total tax, cash by customer and balance. Total tax, private big decimal total, private big decimal tax, private big decimal cash by customer, cash by customer, private big decimal balance. Okay, so next what we might be interested in is adding the access methods, total, tax, cash by customer, balance. Get methods are needed for all of them, but set balance method is not really needed, because balance can be calculated based on the total and the cash given by the customer. So we'll just add them, add all of them, and remove unnecessary ones. Or else getters and setters, ID might be needed, the total get might get, and setters, yeah, we'll just add all of them. Setting the ID might be needed, and total setting the total might not be needed, only getting the total might be needed. The reason is that a bill has a reference to the line items. The total can be calculated. The bill can go about calculating it directly from the line items. So external world, there might be no requirement for the external world to invoke to go about setting the total property directly. So get total is implemented, get tax is implemented, maybe set tax is needed, but I mentioned that I'm not going to implement the tax logic here. And get cash by hand for printing purposes, it might be needed. Set cash by hand, get balance and might be needed. Set balance might not be needed because total and the cash given by the customer determines the balance to be returned if ever needed. You don't need to print it, you don't need to set it from the external classes or external objects. So it's possible to go about maybe adding a toString method, ID, total, tax, cash by customer. Okay, I'll say okay. And a constructor, maybe I'll just have a default constructor which actually does not have anything. Even if I do not add the default constructor, it would work that way. Okay. I don't add a constructor to go about setting all these properties in one go, because you see, the line items are to be added to the bill, so some of these properties are going to change based on line items added. So I don't know the total, I don't know the tax, I don't know the cash given by the customer at the very beginning, so the balance is also not known. So because of that, I am not going to add the constructor that sets all of these properties to this class. If you look at the design here, a bill is a composite object which holds the references to a number of line items. So this association needs to be coded as well. And also a cashier, you see there is another relationship here. So we'll first focus on this association, a composition association. So the bill needs to hold references to a number of line items. So the bill needs to hold references to a number of line items. For that purpose, we will add a list Java util. Yeah, so that's what I need. And I would specify the type as well. Line items, I'm going to hold line items, and I would initialize it to a new array list which would contain which would hold a number of line items. And then of course there needs to be a way to add line items to this. So bill line items, perhaps we add a method which would return the line items. So sections, generate getters, so section, So it just added the method to the bottom of the class. So get line items method is available. Okay, this should be fine. The association is coded. A bill has references to a number of line items. If you look at this, a bill instance would now have a reference to an array list which would hold a number of line items. So that is coded there, and we will code the cashier class, entities, new Java file, cashier, name and ID is available, private string ID, private string name. So you would go about adding the constructors. Sometimes for entity classes you need a no argument constructor as well. So a no argument constructor is also added, and then the setters and getters for all of them. They are there. And if you look at the diagram, the bill has a reference to a single cashier. So the bill needs to have a reference to a cashier. Private cashier, cashier. And you might want to set the cashier and get the cashier. So source actions, generate getters and setters. For the cashier, we will add the methods get cashier and set cashier. Okay, so now this part is done. So these entity classes have been coded, and now we'll focus on the interfaces, point of sale interface. So point of sale, I'm not creating it inside the entities here. Point of sale package, I would like to create an interface called point of sale. And then if you look at the method, the create new bill method, there is a public. You need to look at the return type. You are returning a bill. Public bill. You select the proper type. When you enter here, you need to have selected the proper type. This is the correct type. Bill, create new bill. So that is a method in the point of sale interface. And for the time being, I'll just stop there without coding other things. Bill manager also contains the create new bill. So add the new interface, bill manager, and I want to have the same bill manager, same method. Okay. Item manager contains a search items method. So I will add that as well. New Java file interface, item manager. So it contains search items and a query string is provided, and it returns a list of, let's say, items. Public list of items needs to be returned. Search items string queue. So like that you can implement the interface. You can go about writing the interfaces. Assume that you would be adding these other methods as well. So perhaps for the point of sale, I'll add them so that we have a clearer, we have a collection of methods. Add line item, item ID, and quantity. Add line item. So yes. Public void add line item string item ID integer quantity, and then cash by customer amount passed as a string. Public void cash by customer string amount. Search items queue. Public list of item search items string queue search items, and end bill method is also available. Public void end bill. So perhaps these are the methods. These are the methods that we have already identified, but it's possible that as we complete the coding, even the design is updated and additional methods may have to be added to this. But you get the idea now. The interface is now coded, and the text UI, even that can be coded now. UI package. I will create this time a class text UI, and it needs to hold a reference to a point of sale object. That is an object that implements the point of sale interface. So that is represented by this association. The text UI needs to hold a reference to a point of sale, an object that implements the point of sale interface. So that reference, maintaining a reference to an object, is represented by this association. So for that purpose, text UI, we will code it like this. Private, it needs to point, it needs to hold a reference to point of sale, a point of sale type. Point of sale. So I'll call it POS. And then if you look at the print bill method, so text UI needs to have a print method, maybe public. Text UI, it might not be invoked by someone else, so private void print bill. This has to be implemented. and someone would have to access the point of sale. Someone would have to set a reference to a point of sale object. So for that purpose, we will add the setter method. Source action generate setter. Source action generate. Okay, set POS. It got added here. So a point of sale object needs to be passed, and then the text UI can go about using the point of sale object, the interface methods in implementing its responsibilities. So print bill is one method, and we might actually go about this diagram print bill, we will make it private minus, meaning that it's internally accessible. No other class is going to directly invoke the print bill method. Outside classes will not access the print bill method. If it is declared as private, we enforce it. So it's a private method. Somewhere in another place we might invoke this method, and you see, when the application is started, what we will do is that we will create objects from the classes, link them together, and ultimately an implementation from a class like this, which implements the point of sale interface, an object will be created and it will be passed to the text UI. So if you look at app, so here is the starting point. So what we need to do is that if we look at this design, create a point of sale instance and pass it to the text UI. We can code it here. See, we need to create a point of sale. Inside the main method, we are creating a point of sale instance. So we haven't coded this class yet, but it suggests, you see, this is what needs to be happening. So point of, for the time being, I'll have it null. I have to initialize this. So once the point of sale is created, then what I have to do is the text UI needs to be instantiated. Text UI. See, text UI is available in two packages. I want the one that we wrote, that is this one. Text UI is equal to new text UI. That can be done because here we don't have any other dependencies. Simply a text UI instance can be created, and perhaps if ever we get a point of sale object created properly, we should be able to say UI set POS, and we pass the point of sale object. Now you see, at runtime, a point of sale object reference is available for the text UI, and once it is done, inside the main method, what we have to do is we have to probably pass the control to the text UI. Pass the control to the text UI so that it can prompt the user to enter details and invoke various methods available in the point of sale. So for that purpose, to ask the text UI to prompt the user and continue operations, we might want to say, we might want to invoke a method like, we might want to add a method like a start, inside which we will code that logic user interface logic. So I just invoked a method called start, but if you look at text UI, it doesn't contain the start method, and here in the diagram I will add the method called start, a public method called start, and in the app class, even though I added it, in the text UI it's not available. So because of that, this suggestion, it's underlined in red, and code action suggestions, it asks me to select okay, create method start in type text UI. If I select this, the method will get added to the text UI class automatically. See, so it throws an exception right now, the start method, but here I can go about prompting the user to do various tasks. So now this relationship is established. Only thing is that still I don't know, I don't have a point of sale implementation, an actual class, a concrete class that implements the point of sale interface. So I would go about adding this as well. Point of sale, I have it. New Java file, class, point of sale implementation. I will say it implements the point of sale interface. Implements point of sale interface. So now it's underlined in red because I have mentioned the point of sale IMPL class to be a concrete class which implements the point of sale interface. In that case, all the methods in the interface should be implemented here. I will just use the code fixers and add unimplemented methods. So all the methods got added, but they have to be implemented. So we have the method signatures added to this class now, and if a point of sale implementation is passed to the text UI in the app, see here, point of sale IMPL, now it should be fine, but point of sale IMPL also has restrictions. You cannot have it simply as it is, because a point of sale implementation, a properly initialized one, should have an item manager reference and a bill manager reference. So this is also going to be a bit complicated. So design item manager, reference to an item manager, private item manager, and then another reference to a bill manager, private bill manager. So references to an item manager and a bill manager should be available, because you understand that the methods available here requires a bill manager and an item manager to operate properly. So when I go about coding these, I will have to invoke methods available in an item manager and a bill manager. Okay, so they are added, and someone needs to pass these two to get a point of sale implementation object created properly. So without these two instances, this is not going to work, because these are dependencies. They are dependencies of the point of sale implementation. To implement the responsibilities, an item manager and a bill manager should be available. So because of that, they are called dependencies. So maybe I'll add a constructor to pass them. So section, generate constructors. These two, let's say, needs to be passed. So now the problem is point of sale implementation class contains the constructor which accepts two parameters. So no argument constructor is no longer available. So then I have to create those two first. Create an item manager, create a bill manager. So I will code this. Create an item manager, create a bill manager, create a POS. Okay. So create an item manager. Item manager is equal to new. Well, I don't have an implementation class here, so I cannot initialize it directly. Bill manager, and then the point of sale can be created, because into the constructor the item manager and bill manager can be passed. Item manager, bill manager can be passed. Okay, these two I need to implement, item manager and bill manager. See, item manager and bill manager, so they are interfaces, and I want the classes. I can only create objects from classes, so I will create an item manager IMPL and bill manager IMPL. I will create those classes, and then item manager IMPL. This implements item manager, and then you want to go about adding the methods, all of them, and then point of sale new Java file class bill manager IMPL, and you want to say implements bill manager, and let's add the methods, add the unimplemented methods. So still the other methods have not been added, that's why it appears like this. So given that the classes have been coded, now our app item manager can be created. New item manager implementation, bill manager, new bill manager IMPL. Okay, so look at our application. An item manager is created. An item manager is created from this class. A bill manager is created from this class. See, application, item manager is created, the bill manager is created, and then what we do is those references are passed to the point of sale implementation. See, those references to the item manager and bill manager are passed to the point of sale implementation. So point of sale implementation constructor saves them internally. So according to the diagram, these references are available now, and the point of sale implementation is a point of sale interface implementing class. So that particular object implements this interface. So this interface is passed to the text UI, See, the POS is passed to the text UI instance, and the text UI instance's start method is invoked. So this start method is invoked, and assuming that all the methods are implemented properly, we should be able to code this now. If you look at this app invokes the start method, and where do we have it? So start method, we can go about coding. We will remove it. Java version 25 has the IO class, and I will print a string. Say this is the initial prompt, and if something is typed, I will just say string response is equal to IO. We do have something like this. We can read ln. We can simply say POS starting, and then the user is shown a prompt, and based on what is typed, we should be able to do something. So maybe we want to do this in a loop, so that until a certain condition is met, we want to continue prompting to enter various strings. So while true, we can go about coding it like that, and if maybe if sorry quit, if the cashier enters quit, let's say we want to quit, if it's equals response dot to lowercase break, sorry, we print a line so what we have coded is that so what we have done is inside the start method, in a loop, we prompt the user, we show this prompt, and if the user types Q, we stop the program, or we stop the loop, we break from the loop. So this loop, we break it, meaning that lines after this will get executed. So in our program, we don't have to do anything, because when start method finishes, according to the app, the program will finish. So text UI. What if the user types something else? So let's say we use a switch statement, and if the response is we might also want to do something like this. If Q sorry, equals response. If the user to the prompt, if the user does not type anything, we would simply check that and prompt again. So we might show a message like that and continue, meaning that the loop logic will get executed again from the beginning. So otherwise, the user has not typed Q, the user has not typed an empty string. So in that case, based on the response, we do something. So let's say the user types, according to the diagram, we have create new bill. If C is typed, let's say, or you can write it in full. Let's say if user types create, you need to go about creating a new bill. So how can that be done? According to the diagram, create new bill method, a bill is created. If you invoke the create new bill method of the point of sale interface. So we will simply invoke this, capture the response, text UI. So point of sale, now we have a reference to the point of sale, create new bill, and a bill is returned, and that bill we will maintain a reference to this bill here. Private bill, you can simply say bill. So this bill is set. Bill is equal to, so if the user types create, then the create new bill method is invoked, and the bill object is set now. Because according to the design, the interface should return a bill. So for printing purposes, we may use this bill reference. So text UI, a simple implementation here is io.println, the bill is printed, but we need to implement this in a better manner, how a bill is printed with according to some format. Anyway, the start method, at the beginning POS starting is printed, and if ever the user types Q or empty string, if the user types Q, the program is terminated, the while loop breaks, so no more lines of code is available, no more code is available. If the user types an empty string, we ask the user to type again. You don't have to do that as well, because you can actually have the while loop by default. If a match is not found, we can say io println we can simply type like that. So again the loop will get executed. So even though the logic has not been implemented in full, you see we should be able to run this and see our app run without debugging. See, the start method as we implemented. So if we type Q here, so it works, and if we run again, hit enter, so it didn't understand the command. Create, we coded it to create a new bill. Oh, unsupported exception. That's because we haven't implemented the methods yet. We haven't implemented the text UI. We go about see invoking the create new bill method, but the method text UI line number 31. See, line number 31. So it invokes the create new bill method of this class. Point of sale implementation class, line number 21 is gets executed, line number 21. So it throws an exception. We should implement this properly. So if according to the diagram, the create new bill method, we wanted it to invoke the bill manager's create new bill method. So the interface is implemented in the bill manager implementation class. So we invoke the create new bill method of the bill manager implementation class now. So we want to invoke the bill manager's create new bill method. So here bill manager create new bill method is invoked, and what is returned by that is returned to the caller. So return that. Okay, so bill managers create new bill method is invoked. Now what we have to do is bill manager implementation is the create new bill method implemented properly. So right now it doesn't have anything. So how can we create a new bill? If you look at a bill can be created just by invoking the no argument constructor. So bill manager interface bill is equal to new bill. So we can simply do it like that and return the bill. But you see, in reality, you might want to go about invoking other things, for example, setting the bill ID. So those such logic can be implemented here. For example, just to show that, private integer last bill ID is equal to, let's say, 0. Bill dot set ID, a new bill is created and last bill ID is incremented, and that is used and the bill is returned. So then second time a bill is created, one would be available here just for demo purpose. A database call may be used for this purpose. So just to create a new bill, I implemented this. Even if you want, you can code it like this: private void create new bill ID. Well, maybe perhaps we'll not make it more complicated. Okay, so if you look at the bill, do we have a print method? Yeah, bill ID is printed. Okay, so what we did was we simply went about implementing the create new bill method completely. But for the demo purposes, we just go about having the last bill ID maintained within this class itself. We increment it and set the new bill ID and return that particular bill. So according to the diagram, what happens is that the bill manager implementation, the create new bill method is returned. Bill manager, okay, this bill is to be according to the diagram, the newly created bill is to be maintained here, current bill. So bill manager implementation, so we will code it private bill current bill, and it is the current bill that needs to be created. Refactor, or rather, can I just rename symbol? Okay, because the bill manager needs to have a reference to the current bill according to the diagram, because add line item method will add I line items to the bill and so on. So because of that, the current bill reference needs to be maintained, that is created by the create new bill method. So we set that and then return the newly created bill. So that has been coded here. Now if we look at our text UI, you see the create method would run and still the printing is not available. So text UI, if we just run the application again, let's see what will happen. This time the exception will not throw. So create, see the bill got created. We would like to print some details. Text UI IO print len new bill created, bill ID. Simply the new bill ID is printed. The bill contains a get ID. Okay, see. So we'll quit and we'll execute again. Create. Okay, if we type again, so that logic is getting executed, but the problem is the UI, text UI needs to be coded in such a way that if the create is invoked again and again without finishing a bill, it should not allow new bills to be created. It needs to be coded correctly. So right now create, I can go about creating bills without finishing them, which is not ideal. But anyway, it's possible to go about completing the program now. You see, I simply demonstrated how a bill is created. So the start method inside goes about prompting the user to enter various commands, and accordingly inside the start method, the different methods available here can be invoked. For example, let's say the to print the bill, maybe we'll implement it. Let's say that there is a case to print the bill, case print, so you can implement it. Print bill method is invoked, and we finish the switch case there. So now print method is also available. However, we need to go through the line items and print the bill properly. Right now it's just invoking the toString method of the bill that gets invoked when the println method is invoked like this. So let's quit. Quit and execute again. Create, print. See, that also gets invoked. So we don't have any line items. We are not even printing the details of line items, but this is how it can be coded. So now, of course, what we need to do is that according to the diagram, let's say that some other methods is invoked, line item is entered. So for that purpose, maybe text UI, another command is, maybe I'll just show that. So print is available, and another case might be create a line item. Maybe I'll just print, if ever item is printed. So we need to ask the user to enter the item ID. So string item ID is equal to IO, and so we ask enter item ID. So we assume that an item ID is read, and if the item ID is read properly, maybe we read another thing, that is quantity. IO read prompt enter quantity. Assuming that both are entered properly, you see, if you look at the diagram, add the line item with the item ID and the quantity can be invoked. So we can code, you see, point of sale, add line item, item ID is entered as a string, and quantity needs to be entered as an integer. So right now we have it as a string. So what we can do is we can use integer, pass integer quantity. So that way the line item is added. See, if you look at the diagram, add line item method accepts item ID and quantity. So we have coded the text UI logic in such a way that if item is typed at the prompt, the system asks to enter the item ID and the quantity, and if they are provided, we invoke the add line item method of the point of sale. So what happens when the add line item method of the point of sale is invoked? We need to implement the method properly. So from the item manager, maybe other methods are needed where an item is identified, and then OLs, according to this diagram, we do have the add line item method here. So point of sale implementation should actually invoke the bill manager's add line item method. So add line item method available in the bill manager should be implemented in such a way that a new line item is added to the bill. So this logic needs to be coded so that a new line item is added, and even the print method can be implemented to print all the line items and so on. So like that, little by little, it's possible to go about complete the coding. So if I demonstrate the entire system code coding, that's going to take several more hours. So let me not go into the details, but I will add the sample code that I will finish in the course with the participants, so that the code will be added to the Git repository. So you will be able to get a chance to look at the completed code, but the idea is the same. Methods available in the point of sale are invoked by the text UI, and they are implemented within the class by using other classes. So the complete object-oriented system ultimately contains a number of interacting objects where methods available in objects are invoked by other objects. So we can visualize the system, an object-oriented system, to be a collection of communicating objects. So that is how a system, an object-oriented system works. Let me wrap up now. We spent a lot of time, but we discussed a lot of topics at the beginning. What we did was we had the requirements specification, and from that we went about creating a domain model. This domain model itself is not complete, but it's fine. We can refine the requirements domain model and design in iterations. And once the domain model was created, we used the information available there to go about coming up with the design. So design requires looking at the requirements again. So domain model and the requirements were used to come up with the design. And once the design was done, we went about coding several methods to show you how it's done. And you can go about completing the methods, or else you can look at the Git repository content later on, which would demonstrate, which would have some more methods of the system implemented, some more methods of the point of sale implementation class, bill manager implementation class, and so on. Some more of them will be completed, will be available in completed form in the Git repository. So make sure that you look at the final code as well. I'm not sure whether I will implement it in full, but beyond the finished place, beyond the place where I finish this video, some more code fragments will be completed in the design, and that code will be available in the Git repository. Thank you.